Connecting the dots is it requires some creative thought to be able to kind of like put things together and come up with the big picture idea and figure
Yeah,
things out. So is it known? Is REM sleep important for that?
yeah, it does seem to be. So if there is, so I mean, we could take a step back and think about how does sleep achieve memory processing, learning, information processing? And sleep seems to be important in at least three ways. First, you need sleep before learning to actually get your brain ready to initially soak up new information, to initially lay down new memory traces. But you also then need sleep after learning to take those freshly minted memories in the brain, particularly in a region that we call the hippocampus, which you could think of almost like the informational inbox of your brain, that it's very good at receiving those sort of new memory files. But you need sleep after learning to take those new memories and then essentially hit the save button on them so that you don't forget those informational pieces of the puzzle. So sleep before learning to get your brain ready to acquire information, sleep after learning to hold on to those individual facts.
So let me get this straight. So if you want, for example, short-term memory, right? Because
Yeah,
if you're sort of wanting to store things in the hippocampus, even short-term, that would be sleep before.
that's right.
And then if you want to then consolidate it and have a long-term memory, that would be your sleep after.
That's sleep after.
Okay.
So you can't cheat sleep on either side of the memory equation. You can't pull the all-nighter and hope to be able to continue to learn. And we did this study. We said sort of, is it wise to pull the all-nighter before the exam? So we took a group of individuals, assigned them to one of two groups, a sleep group and a sleep deprivation group. Sleep group, they get a full 8 hours of shut-eye that we measure here at the sleep center. The deprivation group, we keep awake all night under full supervision, and they don't get any naps. There's no caffeine. It's miserable for everyone involved, and no caffeine at all. And then the next day, we placed them inside an MRI scanner, and we had them try and learn and cram, essentially, a whole list of new facts into the brain, into the hippocampus. And the first result was that the sleep deprivation group was about 40% more deficient in their learning ability. So they learned 40% less, 40,
That's
which is
astronomical. That's a huge
non-trivial.
Yeah.
I mean, if you want to put that in context, I guess it's the difference between acing an exam and failing it
Right.
miserably, 40%.
Totally.
What was interesting, though, was what was going on in the hippocampus, this informational inbox of the brain. When we looked at that in those people who'd had a full night of sleep, you saw lots of healthy learning-related activity. It was beautiful. In the sleep deprivation group, we actually couldn't find any significant signal whatsoever. And so it was almost as though sleep deprivation had sort of shut down your memory inbox, and any new incoming files were being bounced. And we put forward a theory as to why that was. Perhaps that the hippocampus, being a short-term reservoir of memory, has a limited storage capacity.
Yeah.
Perhaps a little bit like a USB stick. And you have maybe in humans a 16-hour recording capacity for information acquisition before you have to sleep. Because it's during sleep then after learning. So that's sort of the story before learning. It's not great. We can show it. We know in the brain what part of the brain is failing to produce those impairments.
In that study, you were testing the ability to acquire new information.
Exactly, to sort of lay
Right.
down those fresh memories and just to grab hold of them. And you can't do that well without sufficient sleep. And that seems to be in part related to your non-rapid eye movement sleep or your non-REM sleep. But then what we've also done in lots of studies, and we and lots of other people have now replicated this finding, sleep after learning then takes those memories and I said sort of it hits the save button on them. It's a little bit crass. Actually, what really happens is that during sleep, there is a file transfer mechanism that takes place at night, that we shift memories from that short-term vulnerable storage reservoir, the hippocampus, and we move them out to the long-term storage site within the brain, which is the cortex, which essentially acts like a hard drive. And that means that when you wake up the next day, there are two delightful benefits. First, having shifted those memories from the short-term vulnerable reservoir to that more permanent, sort of safe storage haven in the brain, they're protected and they're safe. so that you're going to remember rather than forget. The second benefit, however, is that sort of having cleared off those files from the hippocampus, almost like shifting files from the USB stick, you've cleared out all of that fresh memory encoding reservoir so that when you wake up the next morning, you can start acquiring new files all over again. So it's this sort of elegant symbiotic system of memory that happens.
Yeah, beautiful.